Good morning.
Morning.
Man, I barely made it in time. I didn't realize it was that close to time to start. Okay, so when we left off our fearless adventure yesterday, we were talking about inverses, and I think I've put it up there before. Maybe I'll put it up there one more time. Solving is the inverse steps in the... Oh, you can't see it. Solving is the inverse steps in reverse order. Probably one of the most profound thoughts you should consider when talking about algebra. Now, a graph of that is probably one of the most important things you should recognize, is that the graph of an inverse function is a reflection of the function itself across the x equals y axis, or not axis, line. So that diagonal line is the reflection of your function. Today, we are going to do some more work with inverses. And this is probably one of the most fun things about inverses, is what we're going to be... Oh, yeah, I heard that. It's not going to be fun, Kevin. Okay, I think it's going to be fun. How do you like them beans? All right. It would have been nice if they would have explained why they show the bicycle lanes here in this picture. It's possible they're trying to show that you go backwards and forwards, but you have to do it like upside down when you go in the opposite direction. In order to make it look like it's going in the right direction, you have to like flip it over. That's possibly what they're trying to show. I'm not real sure. Hey, have you ever seen one of these like this where it's painted green?
I think so. Oh, somewhere in Eau Claire.
There is somewhere in Eau Claire that has it.
It's right next to Taco John's.
It is right next to Taco John's. One of the most important things that you should do when you get to Taco John's is do not turn right on red. There's a sign there. No turn on red. I don't know why they do that. No, what it says, when you see these greens, you're not supposed to drive on the green. Well, at that corner, you have to drive on the green after the light turns. But you're supposed to stop behind the green, and then the bicycles are supposed to fill in that spot in front of the green. When I was your age, I got a ticket for turning left on a street on my bicycle because I was in the left turn lane. And I said, well, where was I supposed to turn left from? Well, bicycles don't pay for the road, so they have no right to it. That was what the Altoona policeman said. It's like, whatever, Altoona policeman.
That makes sense that Altoona policeman would say that.
To me, roads belong to everybody. Yeah.
Technically, people on bicycles do pay for the roads because the roads are paid through taxes. Everyone has right to the road.
Even walkers.
Yeah.
Hey, did you hear what happened in the Twin Cities when they would protest something happening?
Oh.
They would go out into the middle of the freeway and just stand there.
Oh, yeah.
That kind of over off. They did that during, like, the Super Bowl or something like that last year. And it was To do something just for the sole purpose of ticking people off seems like an awful big waste of time, and it makes you look crotchety. I'm just saying.
Have you heard it's on Facebook all the time, but it's a story about some people that were protesting in a farmer's field, and he went out with a manure spreader and turned it on.
That's kind of funny. I have one of my former students ran a cafe in a little town, and during the annual parade, he would take his dad's manure spreader out, and on the side of it, the manure spreader, it said, "Come to Phil's, he puts on a good spread." So, page 157. That was Phil's sense of humor. In recent lessons, we've been looking at functions that reverse one another. Examples of two such functions are multiply by 3 and divide by 3. Here are the formulas for the functions. 3x, x over 3. Now, how are these two functions related to each other? A, B, or C? See if the person sitting next to you knows what it is.
Probably not me, guys.
Would everybody agree it can't be A? Let's go through what A would be saying. A would be saying 3 over x equals negative x over, 3 times x. 3 times x equals negative x over 3. Is that true? If I take 3 times a number, that's the same as dividing that number by 3 and changing the sign. 3 times 3 is 9. That's the same as 9 divided by 3 negative. No, that's not the same thing. Let's go to the next one. G of x. G of x is the x over 3. Equals 1 over 3x. 9 divided by 3 is 1/9. That doesn't work either, right? Let's look at the last one. Composition of functions. Okay, so here is the function. All right, I'm going to take the input, put it into this machine right here, and it is going to multiply that by 3. Okay? Then I'm going to take that out of that machine, put it into this machine, which divides that by 3, right? What do I get out as my output over here? That's what G of f of x means. G of f of x means input x, output f. Input f, output g. And when you get done, what does it say? F of g, or g of f of x. What does it say that's supposed to be? X. That's what that last one is saying. If you input x into f of x, you take that output and put it into g of x, you should at the end get x back. That is the definition of an inverse. Now, it's also written this way. G of f of x is G circle f of x. That circle means of. So G is a function of, f is a function of x. Now, we can have two functions that are next to each other. My grandson was trying to say, hey, Grandpa, I can come up with a secret code in which you need the code to answer the code to figure out what the thing is saying. And I said, in code work, they have figured out mathematically, you can't have a code that you need to have a code in order to figure out a message. You can just skip the second code and figure out a code that works for both of them. Cryptography figured that out long ago. There are many places that use cryptography. One of the most important ones nowadays, your charge card. Okay? You stick your charge card into the machine, right? And it's got a little chip on it. That chip says, I'm thinking of a number that is divisible by this number. And it tells that to the bank. And the bank says, oh, I can take your number and I can tell you this number that it is if you divide it by that number. And then both of them can figure out what that secret number is, and they use that secret number to make their transactions. Nobody except those two, the chip and the bank, has any idea what that secret cryptography number is. That, I think, is an amazing thing. I'd love to learn more about that. I'd love to be the guy that can use that kind of information, because that would be powerful. That would be a powerful message. The other place that it's useful, of course, is cryptocurrency. Right? They've got those little chips that you use when you buy those. What's that stuff called? Bitcoins. Yeah. Okay. What's that?
Are bitcoins even an
Oh, yes, they are. A couple years ago, during this class, we kept a daily record of what cryptocurrency was doing. And we started out, it was like $1,000, and by the end of the semester, it was $20,000. It had increased 20-fold in that much time. And we were like, damn, we should have bought some back in the day. But like you said, there is very little actual cryptocurrency out there. Are you hungry?
Oh, yeah, just in case.
Oh, just in case.
Yeah.
There's very little actual cryptocurrency out there, and so you're probably right. It probably is a dying fad, but I can tell you this. The people who are into it are really into it. One of the advantages that it has is if you are a drug dealer, exchanging money via cryptocurrency is the way to go. Because you don't have to, get a bank to take your illegal money and transact it. You can just do it in cryptocurrency. It's definitely the way to go if you're a drug dealer. In a math lab, right? Here we go. Page. Yeah.
No, I was laughing at your joke.
Oh, A+ for the day. You are my new favorite student since my former favorite student has lost favor. Okay, it's all about former favorite students. Okay, here we go. Bottom of the page. Verify that 2x plus 4 and x minus 4 over 2 are inverse functions. Okay, so here, let's go through it. If a function is an inverse, you start with x. Okay? What is the first thing that f of x did to that x? multiplied it by, and it got, and then what did it do? Added 4. Got it? And it gave you 2x plus 4. Okay? What's the first thing that we're going to undo? And when we subtract 4 from this, we get, and then what are we going to do? And we get x. So f of g of x equals x. If we started with x, we go through f, then we go through g, we end up back at x. That is an inverse function. So they give us one that is page 158. You do f of g of x and g of f of x. So you have two things to do with those two functions to see if those are inverse functions. Go. And while you do that, I'm going to take attendance. I don't know if I took attendance yesterday. I don't think I did. I'm not positive. Oh, yes, I did. Oh, I marked everybody present. No, I didn't. Page was gone. And maybe Jake. I can't remember. Were you gone yesterday? No, 2 days ago you were gone. Okay. Nick's here. Michael's here. Melena's here. Gavin is not here. Janae is not here. Felicia's here. Nicole's not here. Eric is here. Phil's here. Grant's here. Connor's here. Paige is missing. Eric's here. Laura's here. Madeline's here. Jessica is gone. Lauren's here. Jake's here. And Sam is here with tuna and peanut butter both. And a toothbrush.
For afterwards.
For after he consumes 4 cans of tuna fish, and 2 jars of peanut butter. All right.
I don't know what you're talking about.
Did everybody get them? Let's just make sure. So we start with, let's do f of g of x. In other words, we start with g of x. So we start with x. What's the first thing that we do in g of x? Multiply by 3, and we get 3x. Then what do we do? Subtract 1, and we get 3x minus 1. Then it says do f that function. So what's the first thing that we have to do is add. No. Not on f of x. What's the first thing we have to do? Divide by 3, right? So we get 3x minus 1 over 3. Now that could be simplified to x minus 1/3, correct? Then take that number, and what does f of x tell us to do? add 1, right? And so we get x plus 2/3. So, do we end up with where we started?
No.
No. We did the inverse operations, but we didn't do them in the reverse order. Everybody agree? So we did the right things, we did them in the wrong order, because the opposite of multiplying is dividing, but we didn't do it second, we did it first. Okay? So doing the inverse operations in the same order, right? Because they did addition, they did multiplication, we did division. They did addition, we did subtraction. So that's the same order, is not an inverse function. Okay, on the test, you're going to have to see which one of the operations is an inverse function. The only way to do that, at least that you know of right now, is to go through this process. Do the steps one way, and then see if doing them the opposite way results in the same function. Page 158. Oh, we have to do the other one. G circle F. So we do we start with F. F says take X and divide it by 3, and we get X over 3. Then it says take that and add 1, and we get X over 3 plus 1. Then it says G that function. Okay? Well, the first step of G is to multiply by 3. So times 3, we get 3 times X over 3 plus 1. Well, 3 times X over 3 is X. 3 times 1 is 3. Correct? Then it says take that and subtract 1. So you get X plus 2. Now, not only are G and F not inverses, but F of G of X and G of F of X don't even give you the same answer, right? This one is X plus 2/3. This one is X plus 2. Madeline.
So what you do is, I'm not even 100% sure what we're doing here. We're solving for the first F and then doing G.
Okay, yeah, and that's what I'm trying to show you. So let's go through it. So you see what the arrow means. The arrow means you start with X. Why do we have to multiply by 3 first in that equation? Because if we would have added 1 first and then multiplied by 3, we would have gotten 3x plus 3.
Okay, so we're undoing everything.
Right. Now, how do you know which thing to do first? Let's talk about order. Oh, I heard it. This is the order that you go through the steps. Lemdas. This is called order of operations. This is called order of solution. So the order of solution is SAD MEL. We do everything exactly opposite. Now, I know some of you learned PEMDAS, but I don't like PEMDAS because the opposite of addition is subtraction, or the inverse of addition is subtraction. The inverse of multiplication is division. The inverse of exponents is parentheses. No, it's logarithms. Oh! Plus, I like SAD-MEL better than SAD-MEP. Because MEL is sad. Yes?
I don't really understand how that last. How did we end up with x plus 2 and y bracket 1?
Okay, let's go through it. Here is what F says to do. F of x says, step 1, the first thing to do is to divide by 3. So that's what we did. The second step is to add 1. So that's what we did second. Got it? Then let's look at what the steps of g of x are. G of x is 3x minus 1. So the first thing we do is multiply by 3, and then we subtract, we subtract 1. Okay? So, if we start with 3x minus, where were we? Oh, x over 3. If we start with x over 3, add 1. And we want to g that function. We want to g that x over 3 plus 1. How do we go about doing it? Well, g says, what's the first thing we do in g?
Multiply 3x.
Multiply this by 3. Okay? And what do we get when we multiply it by 3? We get 3x over 3 plus 1. Can you simplify that, young man? Yes, I can, he says. X divided by 3 times 3 is x, right? 3 times 1 is 3. So this step right here simplifies down to x plus 3. What does g tell us to do after that, after we multiply by 3? Subtract 1. So now we're going to take that and subtract 1. And what do we get? X plus 2. Where did the 2 come from? It came from starting with f of x. So we went through the f machine, right? We started with x in the f machine, and out of the x machine came x over 3 plus 1. We took that x over 3 plus 1 over to the g machine, put it into the g machine, and when we got out x plus 2, right? One of the difficulties is that the F machine actually had 2 steps. I used to play this game with my students, okay? I'm thinking of a rule that has 2 steps. Give me a number.
4.
21 is my output. When you know what my rule is, raise your hand. So give me another input. 41. When you know what my rule is, raise your hand. Ooh, is that a hand raising there, Grant? No.
Me?
Who is that? Who is that on the end there? I thought I saw your hand raising. Yeah.
Oh, I was stretching.
Oh, okay.
Double is and 1.
That is the rule, doubling plus 1. Now, somebody else think of a rule, and let's see if we can figure out what their rule is. Who's got a rule?
My first one's 1, my second one's 2, my third one's 3, my fourth one's 4.
I'm going to say you do not have a 2-step rule. You only have a 1-step rule. What's her 1-step rule? Yeah, it's supposed to be a 2-step rule, sister. Okay? So somebody think of a 2-step rule. You got one? A two-step rule?
No, I was gonna do the same thing.
Oh, okay, you were going to do the same rule she did. Okay.
1 equals 2, 2 to 3, 3
One.
to 4.
1 equals 2, 2 equals 3, 3 equals 4.
Yep.
That sounds like her rule.
I have an extra step. I have the 1x plus 1.
So you sound like Uriah. Uriah said, is there a way that I can have a rule that you need another rule in order to get the answer? You can simplify his second rule and just say, I don't need that step, and just take x plus 1, right? Yes?
Is there another way to do this? Because I remember doing this in high school, but we always took like G, if it was like F of G, that.
Yeah, here's the way that you probably learned it in high school. You probably learned it like this. If f of x is x over 3 plus 1, you probably learned to say, well, and actually you couldn't even do it as a function. You had to do it as a y.
Okay.
And they told you, switch x and y, and now solve for x. So subtract 1 from both sides, and you get x minus 1 is y over 3. Multiply both sides by 3, and you get y equals 3x minus 3. That's the way you learned it, probably. But if you notice, what's true about that is that gives you the inverse of f of x. But it doesn't tell you what the relationship between f of x and g of x is. It only tells you what the inverse of your operation is. It doesn't tell you whether two operations are inverses of each other.
Well, if they equal each other, they'll be inverse.
If they are exactly the same, they will be inverses. You are correct, sir.
So I can do the same thing to the other one, just flip the x and y, and then if they both equal 3x minus 3, it's the same.
Right.
Okay, I think I'm gonna stick to that way.
That's fine.
So it's too much thinking for the other one.
In my mind, my method involves no thinking. I make the arrows, I do the steps. The other thing that I like about mine is I know for a fact I have to do the inverse operations in the reverse order. Okay?
See? That's why I'm like, I don't know.
Okay? You just keep telling yourself whatever you want to tell yourself. I can tell you this. This is the best way I've ever seen to explain inverse operations, to explain order of operations, and to explain inverses. I've never seen it explained a better way. And I've taken and taught algebra for longer than you've been alive. I think. I started in 1981.
Yeah, I was born in 1999.
1990 what? I don't even have kids that young. I almost have grandkids that old. Let me think. She's 15. Nope, not quite. Okay, here we go. Inverse function notation. One of the things that they do very poorly is the inverse function notation. G of x is f negative 1 of x. So one of the things that they say is if f of x is 2x plus 4, f negative 1 of x is x minus 4 over 2. It says those two are inverses of each other. The part I don't like about it is it makes it seem like for the inverse we put x into the equation, but we don't put x into the equation. We put the answer into the equation. So if you look back a few days ago, we were doing this one right here. We started with t, we squared it, we multiplied by 4.9, we got 4.9 t squared. They say start with t. No, that isn't t when you get that answer, that's d. Divide that by 4.9, square root that, you get d over 4.9. Okay? These two, d equals 4.9t squared, and t equals plus or minus square root d over 4.9. Those two are actual answers. I don't like the way they write inverse functions. Now, one of the other things that is true is that that notation is really close to the derivative notation that we use in calculus. So it's kind of confusing to students. You have to notice subtleties about it in life that it takes a little bit of practice to know. To me, it's like fishing, okay? The difference between a white crappie and a black crappie, the difference between a walleye and a sauger. I mean, you've got to recognize those differences. Hey, if you're hunting, the difference between a pheasant hen and a pheasant rooster, that's an important distinction to make because nobody's a hunter of pheasants.
You can't shoot hens.
You can't shoot hens.
Legally.
No. I like that. Yes, you are correct.
New favorite.
Here we go. Page 168, number 4. Find the inverse of 7x plus 3. How would we go about finding that inverse? F of x is 7x plus 3. I'll give you a hint. Start with x. Go.
Oh, I'm done.
See what I did? So I went through the steps. 7x plus 3. So I multiplied by 7, then I added 3, and I got 7x plus 3. To find the inverse, I start with x, subtract 3, I get x minus 3, divide by 7. Inverse operations in reverse order. Table. X, f of x, negative 3, 0, 1, 5. X, g of x, negative 2, 4, 6, 14. All right, I need, and then f of x is 2x plus 4. And g of x is x minus 4 over 2. I need these the front half of this table and this table to do f of x. So you fill in the f of x table. I need this half of this table, and Menominee to do g of x. So give me your outputs for those inputs. Anybody need some help on how to get started? Or you know what you're doing?
I'm already done.
Or you're already done? Gavin, you know what you're doing?
Yeah.
Connor?
Yep.
Lauren? Yep, you're pressing buttons. That's a good sign. Felicia? Are you pressing buttons? Are you pressing the right buttons? Eric, you okay? Oh, he's not there.
Yeah, he's okay.
Must be okay. What do we got? What'd you get, Eric?
-2,
-2.
4, 6, and 14.
What'd you get, Marlena?
I haven't gotten that far yet.
Okay. Laura?
-3, 0, 1, and 5.
So, on the test, there is a question that says, hey, these two are inverses. Come on. These two are inverse functions. It will not even give us the rule. It just gives us the table. How do we figure out what the other values are? Well, if they give you the input to one function and the input to the other function, what's going to be true? The output of one is going to be the input of the other. So, for example, let's say that we did 6 over here. Well, 6 times 2 plus 4 is 16. Is that right? 6 times 2 plus 4 is 16. Okay? And they told us on the other side, how does that reflect over here? Well, if this is 16, this is 6. How about if this is 6? Would this be 16? No. The input of one is the output of the other. Okay? Page 158. So if you think you're so smart, fill in the table here. Notice they aren't in the same order, so you have to kind of go through things to figure them out. 3 is 10, 5 is 5, 9 is 4, 11 is 1. 1 is 11. 4 is
9.
5 is, and 10 is. Everybody good? Makes sense? Okay. Do the next one. So we have x 1, 3, 5, 7, 9. F of x is 2, 4, 2, 1, 7. Over here, x is, and then f negative 1 of x is. Now, they didn't give us the rule, right? The input of 1 is the output of its inverse. So, start with 2. What do we get? 1. 4. What do we get? 3. 2. What do we get? 5. 7. Nope, I'm sorry. 1. What do we get? 7. And 7, we get 9. Okay? So it's pretty easy to do inverses.
So since there's two answers for two,
Ooh, I was hoping somebody would notice that important fact. I was trying to trick you. Do you see that Nick is right? That is not a function because one input has two different outputs. All right? That test that we had on chapter 1 and people got the Q1, Q2 business screwed up on the table. There was one person that got the Q1, Q screwed up on the retest. All right? We need help. Was it you?
I don't know. I don't think so. You had me thinking.
The important thing is make sure that you notice those kinds of things. That's an important characteristic to look for. If you have one input with two different outputs, it is not a function. So if I tell Lauren that if she tells me the input is 2 and I say the output is 1, and then Nick says the input is 2, I tell him, the answer is 5. Do you see how I screwed up the function? Because the machine can't give two different answers. It can only give one answer for each different input. That is that. Page 161. The inverse of a quadratic function. Let's look at this quadratic function of a golf ball.
I thought we were done.
S of t is negative 4.9 parentheses t minus 4 squared plus 78.4. This quadratic is written in the vertex form. Where is the vertex? Oops, you can't see that. At 4 seconds. How high is it at 4 seconds? 78.4. The problem is I don't know like what point it goes through on either side. I know it's going to go down. How do I know it's going to go down?
First number's a negative.
And how fast is it going down? What is its scaling factor? Yeah, Laura.
I don't know, but why is it not negative 4?
You are correct. Why is it not negative 4? Let's go back in our minds to that day that we were talking about the input or the output shift. If it's positive, you go up. If it's negative, you go down. But then I said on the input shift, if it's a positive sign, you go to the right. If it's a negative sign, I'm backwards. I have to think this way. If it's a positive sign, you go backwards to the right. If it's a negative sign, you go forward, it's to the left. Now, why does that happen? If you recall the day we dropped I'm just going to draw a sketch here that might help you. The day we dropped the rock, remember it went like that? I think it was 200 feet high. Okay? And then we said, how about if we dropped it 1 second ago? Okay? Do you remember that if we dropped it 1 second ago, it started here and it went down? Remember that? And if we backtracked, we got to this spot right here. Right? So the graph of f of x is shifted to the right 1 from t minus 1. Okay? I'll show you the way I used to teach you, or I used to teach it when I taught algebra. Okay? Here is the map at the mall. You are here, correct? Okay? So you start with where that point is, and then if it says y minus 2 equals 3x plus 3, to find where the origin is, you go in the y direction. In the y direction to, why is that pen not working? In the y direction down 2, and in the x direction forward 3, and you put your coordinate axes there. So from view of the function, there's where the origin is. But we always start with where the origin is. So from the origin, you actually go back 2 and up, back 3 and up 2 to get to the point. We always do it in view as though we were standing here on the origin, but the actual mall map is viewed from where you are. And the reason why mall maps are not a very popular thing, they only work in the mall, by the way. You can't have a mall map in your car. Well, actually, you can have a device that has a mall map in your car, right? You take out your phone, and no matter where you are, right, when you click on the map, here's my map function. When I click on my map, it shows me where I am. And it always puts it right in the center, right? How does it know that? Well, the satellite tells it where I am in connection with the rest of the Earth. The rest of the Earth could give a crap whether I'm there or not, right? The only person that matters to is me. I know it's complicated. I'm in discussions with the Dana Center because I think they need to beef up their way to teach inverse functions. The test questions are pretty dang hard. And it's because your brain has to process things a lot to figure out what's going on. Page 161. So, now I've wasted another page in my notebook. I'll have to start again. S of t is negative 4.9 t minus 4 squared plus 78.4. So I'm at 78.4 and I go down in both directions. Does this function have an inverse? Well, If it does, it's going to be mirrored across this line right here, correct? And the mirror is going to look like this. Oops. Let's see here. I should draw it more like this. What's the problem when I drew that inverse function on my graph? You better not always count on Nick to find this, because this is an important one too.
It's a function.
Because
It's not a function.
Because it doesn't pass the vertical line test. Okay? Since it doesn't pass why doesn't it pass the vertical line test? Because when you take the square root of a number, it's always plus or minus. So that's why the whole thing is not a function. If you only consider the portion of the flight during which the golf ball is rising. Oh, okay, so let's change it. The golf ball is rising. Why do we stop there? That's where it stopped rising. Now, if we draw across our line, okay, we're going to get to a spot right there, correct? Does it pass the vertical line test now? Sure does, right? So it does have an inverse. Page 161. When we come back from our break, we're going to find that it is possible to restrict the domain so that a function will have an inverse. The domain of a function is the same as the range of its inverse, and we're going to find ways to restrict the domain in order to make it a one-to-one and find the inverse of a quadratic function.
Yes.
Wait, you're so slow. Oh, yeah, because I have friends too. Oh, yes. You can just go. I'll go when you go next time.
I don't think I'm mentally ready for another hour.
Same.
Class drains me. You're just showing like this stuff's easy for them. It's like, what are you talking about? Yeah, I woke up this morning and I damn near did not.
Same.
Yeah,
I was like halfway here. Wow, that about turned out.
yeah, exactly. I always stay right there. My brother's in the next class right there.
Your brother is.
Mm-hmm. Graduates in December.
How old is he?
1, 2. Marketing.
Is he good at
No. Nobody in my family's good at that. Nobody.
Believe it.
Wait, I'm all three. My sister, me, and my brother. I literally have the best grades.
When I can.
And
Yeah.
they're like, you're the smartest one out of this three. My parents like just sat me down and told me that. But like, I don't know how to do math or anything.
I haven't even told her this.
What's my high school? It was cultural for me. I was the honors, like, tried so hard.
I just went for a season.
We could bring Chris together.
Yeah, you can if you want.
True. Go on with it. Eric,
You're the kid that never did the homework but went and sat down for the test.
always.
Never made it too far. We get full credit.
Super late, but
Sweet. Are you shit faced?
It's not advantageous.
Mine, I had a crazy.
Acceptable.
Well, yeah, kind
I mean, if you're bad at math, it's in such.
It was classes.
of. I bet your tests were right.
Yeah.
I actually
But I lost.
had a crazy math teacher named Anita Fairbanks. She was such a bad teacher. She would give us like food and stuff, which was nice. But like she cleaned beanie babies and then shits were all over the room. And then like she said, if you guys finish drinking like you're not a problem, right? You got a beanie baby that you can take home with you. So I still have mine. Mine's a pterodactyl.
I'm not.
Got it.
We were
I
just
know
talking about days.
my hate group that I was
Watched
in. I typed it out on Word. Copy everything.
You're good at discussion, but buddies, that could have setbacks
When I entered it,
genuinely needed a good
the last
teacher.
quarter, I rolled.
I had like
Kind
a
of overtime. Right? Like that. Yeah,
good
enough. Whatever. I was having a beer.
That's right. I was like the bottom.
It was almost nothing about There's so little about it. I'm very upset. What you have?
It's not really a sign of intelligence.
Continuity, Irish Republican Army.
Wait, what are your guys' topics?
There's plenty of stuff about the Irish Republican
What are
Army,
your
but the
topics?
continuity
Yours is
part,
like probably something
they're
like.
like a little faction that split off.
Yeah.
And there's nowhere
Yes, I'm
near
so
the- I
excited.
mean,
What's
I
yours?
googled it, and there were 2 pages of
Oh
Google.
yeah, that's right. Yours is
Two.
the song.
I've never had
How
that
much you
search results in my life. And the second page is useless.
Okay, so for a band class,
I'm white national.
literally, we
Mine,
for my senior year band,
muddled up.
we played that song for our Christmas concert, and I had
Like alt-right groups like that.
27 measures of rest. And so literally, at one part, all there is just like bass drum hits
Only everybody got
at the end of
Let's go.
one of the songs,
Yeah.
and the person was playing very sax with
This
me,
is like trying to describe the origins of white
and I
nationalism.
got yelled at, and I got 0 for the
Around before
concert.
the
It was
KKK,
like-
so there's that.
Yeah, but you did.
It was-
Fuck your own band
What's
It
class.
was funny,
rite of
bro.
passage?
It was so funny.
Yeah, that was another one. I was like,
It was so
Alright.
funny.
yeah, just I have nothing.
That's
It's like,
only like
what's your
Polar
group
Express
comprised?
script. I never liked that movie.
It says they're
No,
both.
that's the thing. I wouldn't mind doing
And
it.
they used to be
Like you showed me, I was like, this
But
animation.
nothing else.
No, it's just
Yeah, actually,
They're mostly men, I'm assuming.
The most of my.
I've seen. I'm pretty sure I've seen the whole
By
thing, but
references.
because we had to sit down and watch it in class, like he was saying.
The
But I
like the store
kind of
website.
interested because I
Like,
never
yeah.
picked up on that. Yes, right. There's some weird shit going on because it's just such a shitty movie.
Well, I think
You gotta be
10
doing
minutes
something
later.
while watching it.
I think it's more than the messaging side of things.
It's for people like me.
I think it's one with the last name was Sam.
Like that'll put kids in here if people can stand up.
Jeez, don't hurt yourself.
Yeah. So we're at the applications
I think
office.
they can train is like, and there's some, I like watched the video on it. They did a good break.
Tried to go to the magnet.
But the conductor doesn't die.
Just freaking dope.
No, I know they like that was like a guiding force.
So you get like one cow magnet.
Are you spinning it jokes or are you? Oh my god.
No, there's-
Oh, the
I just seen the
conductor's
movie, so it's
weird.
tough for me to talk on it, but this video is pretty convincing. And it made sense because I understood.
No, that little girl's Jesus, because she got pushed off the train or something, right? They walked her off on the top of the train. I don't even know.
He even says some character in the movie is supposed to represent the Holy Ghost. There's some-
It's a little girl. Bet you not. Polar Express got me right. I bet you.
So from that perspective, it is nice, right?
Because she
yeah.
gets like pushed off the train for stealing that cup of coffee and giving it to her. I don't even know what the person's point is because he was sitting all alone in the other room. Nobody knows why. He just was
The movie makes like a bunch of references to faith too.
Places that you see Wi-Fi, so you can enter in a new path.
like sketches me out. I don't even want to
That's
talk
what
about
I'm saying.
that.
He's like digging through all that.
The only reason why I like that movie is because Tom Hanks.
All these first world problems.
He plays like counterpart.
Oh really?
Those people
He
on
is
the
like
internet
all the
don't know
characters.
how
He's plays like all.
20 miles to water, but staying.
20 miles one way.
I'm fine with
20
this.
miles one way, uphill both ways. Wait, no, it's just turning into my dad's trip to school every day. It was snowing out there. In Africa? Told me, oh yeah, I had to walk to school every
Get your
day.
proposal
I
done?
felt almost a little bit bad for him. And then we visited Jack. Literally, you could not have done
Why?
literally right across the street.
I don't even know about writing. Well, I guess I kind of do, but I don't know how I'm gonna prove it.
It's a tough argument.
See, the thing is, like, I don't know how I can compare because, like, minus the fact that, like, Ushers, like, work was because of the highway. But, like, I don't know if I'd, like, count the number of, like, buildings and businesses that were increased from that time frame. But I don't even know what the start was.
Basically,
Middle class.
partial reciprocal. Clearly, huge.
Well, I live,
Why don't they just?
I live on the
It's like right up there, and all of a sudden you're in Altoona.
Yeah.
It's like I've been.
do you know
No, I look at
Yeah,
where
pretty
the
much.
East Ridge Center is, and then Scooter Hill, that huge hill? So I live in the middle
well, I
of
was
it,
like at like
right next to that
72 or something.
So like literally all you have to do is go up the hill past the stoplight and you're in
So
outside.
that goes to show that you definitely do.
So like I don't really know.
So that's what I'm saying. It was expansion because Claire in general. Every part
How
of
many
it.
points do you have for it's like 38?
Well, I don't know if like the expansion has to do. Well, if you look at the highway,
Did you take attendance?
like come on, like there's a
Yes, here.
part right there. There's a bunch of businesses over by the Fall Creek and do now the huge. I don't know. Okay.
Is that like Cowboy Jack area? They
It's not. It's not up to like, I don't like this because like in high school
Even
before
from downtown to that area is like
7 minutes.
I just
Well, because I live right downtown, and to get there was.
I didn't know where the Amber Inn was until like a week ago, and I've been here also like, oh my goodness, that inn was like up the hill from
Yep, that
downtown.
would be super.
I didn't know where it was until now.
Well, you can go with it.
Because I got one of those.
You should. Yep. Don't have time. It's worth
People say there's no military activity.
No, you're not.
Well, that's how everybody got into Boston. And then Bob's ended up being ex-Marine, so he took her part.
Oh, if anything, you should have done
Like, we're told that. That was 36 no sleep. I was so stressed out. It was the worst time ever. So, like, literally,
Oh, is that what this is?
no, it's
I'm
like
gonna ask
background
for it.
history. You're gonna get the top secret.
So,
Versus
So, like, literally,
I'm allowed to
we
turn
didn't
two
sleep for
things
36 hours, and we got back to the barracks or whatever, and then I was like, go to sleep.
I went
don't wanna hear
downstairs
anybody
too, made it
talking.
all the way to the bottom.
So we're all laying in bed.
Can confirm.
15 minutes later, he
Didn't
goes,
see it
get up, it's time to get up, we're going to
down there. And it's
town.
fine, I had enough.
I wanted to cry. It was the worst thing. And like, we were able to have our rooms
Concentrate
session, but like, you
in
just
IR.
did them. And I remember calling my parents like every night and be like, okay, I don't think I can do this. But I got to take some
We can start.
videos.
So here's the situation. My office is being flooded as we speak. So,
Oh, sweet. So it's class canceled?
no, it's just, that's where I was.
I think that's pretty serious.
It is extremely serious.
I don't think you should take this for granted.
I'm not taking it
Let's all
for
go
granted,
check
but that's why we hire folks to fix stuff.
Wait, it's being flooded?
It is being flooded as we
Can I
speak.
go look at? Can we check
Awesome.
out my last trip down to the?
My office.
From where?
I don't know, they got a leak someplace.
Yes. Let's think about the Mad Max and how to fix it.
We have been in the basement. This is like the 7th or 8th time, so it's no big deal. I learned long ago not to store stuff on the floor, but I've been here for 20 years. If you've been here for 5 years,
You're screwed.
you forget
Wait,
that.
how long have you been a teacher? You said you were a principal and a teacher, and now you're here.
And I'm old. You're forgetting I'm old and crotchety both. Nicole, are you coming in or are you going to stay out there? Okay.
So I think we should go down there and think about how many buckets of water.
How many buckets of water? I can tell you this. Water spreads out extremely thin, and a little water goes a long ways. Paige.
Let's measure how many.
Is there a function for that?
Is there a what?
Is there a function for that?
Actually, the rate of flow is controlled by, the basement is carpeted, which is a good thing and a bad thing.
Let's measure it.
It slows down the flow of water, but carpet gets wet, and then it gets moldy, and then faculty move out of the basement because they're allergic to mold.
So how many square footage is that carpet? Should we go measure it?
How many square footage is the carpet? No, you don't need to measure it because it's probably about maybe 2,000 square feet.
Is that a rough estimate?
That's a rough estimate. Here we go. Decompose the function s equals negative 4.9 t minus 4 squared plus 78. Now, if we would use that, the Madeline way of decomposing this function, we would switch s and t and then solve. Do you see a problem when you switch those s and t around? You might not, but you certainly will when we do the decomposition the way we were supposed to, which is start with start with t. What's the first thing we do to t? Now notice I'm making my steps very close together.
We squared it, or is it before?
Subtract 4, and we get t minus 4. Then what do we do? Square it, right? And we get t minus 4 squared. Then what do we do?
Multiply by negative 4.9. I don't even know. I'm just.
Yep, that's right. And we get negative 4.9 t minus 4 squared. And then what do we do? Add 78.4. And we get negative 4.9 t minus 4 squared plus 78.4. Start with S. Why? Because that's where we end up. First thing we undo, subtract 78.4, and we get S minus 78.4. Then what do we do? Divide by negative 4.9.
So just put it over that.
Then what do we do? Square root that, plus or minus S minus 78.4 over negative 4.9. And lastly, what do we do? Add 4, right? So S, negative 1 of t is square root plus or minus S minus 78.4 over negative 4.9 plus 4. Now, the diagram in question 2, part B, gives rise to two different possible formulas. The first thing I'd like you to notice is, in this step right here, they did a math that makes a lot of sense. They changed every single sign. So instead of the way we wrote it, they would take 78.4, which was negative, now it's positive. Minus S, it was positive, now it's negative. Divided by 4.9, it was negative, now it's positive. So do you see how those two are the exact same thing? We just switched every single sign, which made some orders switch. I like that because then you minimize your negative signs. Now, which of these formulas will give the time during the ascent of the ball? That is from 0 to 4 seconds. So you think about that. Which either you have S minus 78.4, 78.4 minus S over 4.9 square root, away from 4 or added to 4. Well, would you agree that in the first case, the time is going to be bigger than 4 seconds? Would you agree this right here is going to be at least 4 seconds? Because you're adding something to 4 seconds. And that thing you're adding is going to be positive. How do you know it's going to be positive? Because you can't take the square root of a negative number. Okay? Is the time during which the ball is going up into the air, is that less than 4 or bigger than 4?
Less.
Less than 4. And so the one that we're going to be using is not the first one, we're going to be using the second one, which says 4 minus the square root of 78.4 minus s over 4.9. So when we graphed those two, our graph will, the graph of our function goes like this. The graph of our inverse goes like this. Got it? Page 163. So, if you notice, Part A says, here is the flight of the ball going up. Part B says, here is the flight of the ball going down. Lowercase a matches which of those? Lowercase b matches which of those? So turn to the next page there, Jake. You got to have them both open at the same time. Which one of these is the ball going up? Well, one of the things that's easy to notice is this must be going up because it starts at 0. This must be coming down because it ends far away from 0. If this is the time axis, right? Which one is going to be farther away on the time axis? To me, the easiest way to answer these questions is to take your paper, fold it along the x equals y axis, which you can't do because these two they didn't draw symmetrically, did they? This is 1 second and this is 10 meters. You have to have them both be the same units, otherwise that flipping across that axis doesn't work. Okay. Page 164. In our notes of the beginning section, it said, the domain of a function is the same as the range of its inverse. The range of a function is the same as the domain of the inverse. So let's look at graph A. Here is graph A. What is the domain?
0 to 4.
0 to 4. What is the range?
0 to 80, or like 78.4.
Yes, 0 to 78.4. B. What is the domain? Are you writing these down?
4 to 8.
Okay, let's go back. So the first one here, for the first one, the domain of part A. So the choices for x is from, and the easiest way to write it use the brackets, okay? That's the easiest way to write it. And what did you say for the range? Because she's writing it down now. The range for A? What do you get, Lauren?
Isn't it 0? Oh, that's the wrong one.
Yep, capital letter A.
0 to 4.
That was the domain. Now the range?
0 to 70 something.
78.4. And the reason you know it's 78.4 is that's this number right here. Then for B, domain, from 4 to 8, the range 0 to 78.4, right? Okay, then let's go to lowercase a, domain 0 to How far over did it go? 78.4. Range? And then for part B, lowercase b, the last one, 0 to, and then the range, 4 to 8. Now, some people say 8 to 4, but always list them in numerical order, regardless of where they are on the graph. Always list from the farthest left to the farthest right, and from the bottom to the top, regardless of which way the graph goes. Everybody good? Inverses.
Yes, another video.
If I lost this video, I'm going to be upset. Okay, I did. They changed our videos here at CBTC, and I used to store them in a thing called Camtasia. Now they lost the addresses, so it's not there anymore. Okay. So I will have to be a grandfather clock. I'm a grandfather, so all I need to do is the clock part of it. All right? So it has a pendulum, right? And the pendulum goes tick, tock, tick, tock. How long is it between tick and tock?
A second.
1 second. Everybody agree with that? It's 1 second between tick and tock. Okay, so we would say the period of the pendulum is 2 seconds, because it takes it 2 seconds to go from one side and then back again. All right, now at home, this is the video that I had, is at home we have a mantle clock that goes tick tock, tick tock, tick tock, tick tock. Okay, there, 1 second is from tick until the next time it's tick. So the period is 1 second. Now what's interesting is, obviously the pendulum on a grandfather clock is long, and the pendulum on the mantle clock is very short. Okay? Page 165 talks about using a clock to make a unit of length. Now, it's a very interesting process when you think about it. Here's what they used to have to do with measurement. Back when they decided that we're going to go with this metric system thing, okay, they made a bar out of a very expensive metal. I don't know why they used an expensive metal, but they had to make sure they kept it at the exact same temperature. What would happen if the temperature would have increased? It would have gotten longer. If it would have decreased, you would have gotten shorter, right? Because metals expand and contract. And then anybody that wanted to make a meter at their house would have to go to Paris, because they stored it in Paris. Don't ask me why, I don't know. And you would take your bar of metal and make a mark so that it exactly matched their mark, so that everybody would have the exact same meter. Well, that in itself was a vast improvement from the usual way that they did measurement. They used to say a foot was defined as the average length of the feet of the first 12 people, 10 people out of church on Sunday morning.
Wow, that seems really logical.
Okay? So if you were buying land, you would want the people with really big feet to come out first. Why? Because then, that land was only 48 feet long. If you were selling land, you would want the little kids to come out first because then that land is 200 feet long. Okay? So you see how you could kind of like rig the system in your favor? Nowadays, they define a meter as a certain number of wavelengths of the light given off by kryptonite. No, not kryptonite. Krypton. The gas krypton. It's like 4 million wavelengths of light. That's how long a meter is. Why do they need to be so precise? Because of your stinking cell phones. Which, by the way, anybody read the latest on cell phones? Who's the guy? Zuckerberg and Chan. They say people are addicted to their cell phones. Have you heard that?
Yeah.
Because you get a pleasure drug that your body makes every time you use your cell phone. And it is a very addictive drug. And so they say, don't have your kids have a cell phone. Anyway, getting back to the cell phone. Why does it need to know length so precisely? Because it has to figure out what the nearest cell tower is to where you are. Now, do you know where the nearest cell tower is right now? No. Because the other thing that's true is it has to be the nearest cell phone to you that your carrier uses, right? Now, I can tell you there's a cell phone tower on top of the university over here because any place that's tall, the cell phone companies are like, we want to buy a spot on top of that tower. Why? So they don't actually have to build a cell phone tower. It's already tall, right? Okay, so your phone has to know where the nearest cell phone tower is so that it can give your cell phone the right frequency for the radio waves so that it can tell you, that mom's calling saying, bring home butter. Or whatever. I don't know. Maybe mom never calls. Does she text? She never texts and she never calls?
No, she don't have a mom.
Oh, she calls. Does it bother you that she calls instead of texts?
Well, she has a flip phone. So
She
it's
has a
serial
flip
threat.
phone. Oh, poor dear. Here we go. So, in order to figure that out, notice, here is the formula in the middle of our page. T equals 2 pi square root L over G. The part that I think is phenomenal about that, first of all, let's talk about over G. Do you remember we watched that video the other day where the lady was in the space station and she let go of the pendulum? And what happened? It just floated there, right? Because there was no G, okay? So gravity is one aspect of a pendulum. Let's think about if that pendulum were on the moon. Right? It would be going slow. Remember we watched the video yesterday and the hammer and the feather both dropped, but they dropped really slowly? Okay, so if you take your grandfather clock onto the moon, it will not go very fast. Everybody agree with that? Yeah. But here's the part that I think is absolutely phenomenal. It's got something to do with pi. Hold it, pi's about circles. Why in the heck is pi part of the formula for figuring out how fast a pendulum goes back and forth? Don't you think that's cool?
Yeah.
To me, it's amazing.
I think it's kind of cool.
Thank you. You are back on my good list. All right. Now, there's one more letter in there that I don't like, and that's the letter T. Yes, T has something to do with time. T is the period of a pendulum. So remember we were going with this one. What was the period of this pendulum? 1 second, right? What was the period of this pendulum?
2.
2 seconds, okay? So that capital letter T is the period of a pendulum. Number 2, a seconds pendulum is a pendulum with a period of 2 seconds. In other words, a grandfather clock. It takes 1 second to swing tick and the other second to swing tock. Okay. It says you found in preview 11D the period of a pendulum that took 2 seconds is 0.09 or 0.994 meters. Let's do the math. T, 2, correct? Equals. Let's go through the formula. I forgot to write down the actual formula here. T equals 2 pi square root L over G. 2 is 2 pi square root L over G. How did we go about finding that? Well, we start with the length of the pendulum. What's the first thing we do? Divide by G. What's the second thing? And we get L over G. Then what do we do? Take the square root of it, and we get square root of L over G. Question. Is this plus or minus? Do we have to put a plus or minus there? No. Because every number you take the square root of, if you press it on your calculator, you only get one answer, right? Now we call it the principal square root of the number. 49, if you press square root of 49, your calculator says 7. Actually, -7 times -7 is also 49, right? So your calculator kind of fibs with you on that one. So we have the square root of L over G. Now what do we do? Multiply by 2 pi. And we get 2 pi square root L over G. Okay, so let's start with the answer 2. We want that as the answer. What's the first thing we're going to do? 2 pi over 2. Is there a mathematical process that you can go through at this point to simplify that? Cancel the 2's, right? What's the next thing that you do?
Square root of 2.
Opposite of square root is square it. Good. So we have pi squared. And then what do we do?
Multiply by gravity. How come we did 2 pi divided by 2 instead of 2 divided by 2 pi?
I have this backwards, don't I? This is supposed to be 2 over 2 pi So that's cancels. And so this is 1 over pi squared. And then at the end we have g over pi squared. Yeah, I just made that mistake. You're right. So on our calculator, we would press gravity, which is 9.8, divided by pi squared. Um, 9.8 divided by pi, where's my pi button? Oh, pi squared is about 0.992993 meters. Or we could take 9.8 divided by, I'm sorry, Claire. We could take 32, that's gravity in feet, divided by pi squared. And we get about 3.24 feet long. Now, here's why that is such a powerful thing. That works any place on planet Earth. Any place you're on in the world, it will always be 3.24 feet long. So a pendulum this long will always swing back and forth at the same rate. So you could take your grandfather clock any place in the world and it will keep the exact same time that it is where it is now. That length is a for sure. It always works that way. Okay? Oh, by the way, the doorknob is a meter off the ground. Just for you to keep track of how far a meter is. That one looks a little low though.
I think so too.
I think we should.
No, it's a meter.
Is that a rough estimate, Kevin?
No, it's a absolute. Have you ever? Don't you watch those fishing shows where they'll say, especially Pete Mena, he'll say that's a 49-inch muskie, and he takes it out and it's dead nuts right at 49. Not 49 1/4, not 49 3/8. I mean, it's 49. I think that's amazing that people can be that precise about stuff like that. Well, put it this way. If your house is dark and you go over to the door to open the door, you go like this. I know that dang handle's around here someplace, right? Where do you put your hand to open the door in the dark? It's not rocket science, children. Page. Did we finish that page? Oh, nope. We have another square root problem. Consider this function, 2 plus x minus 5. Graph the function on a graphing calculator and get its domain and range. Oh, this is 16. What happened to dice? 11 to... Oh, here it is. So 11D here. Graph the function. Oh, there's our square root function. Yeah, we did that one. Here we go, 11D, the inverse. It says graph 2 plus x minus 5. Square root. If you notice, when I graphed it, it only gave the top half. Okay? Then it says... graph the function and determine its domain. Looks like it starts at about, well, I can click on the point here.
5.
Starts at about 5. And it goes to
Infinity.
Infinity. Starts at, and then the range starts at 2 and also goes to infinity, right? How do you know it keeps on getting bigger forever and ever?
Yeah.
Okay, I'm going to change x to that many zeros. Then I'm going to change y
How do you know if we're just looking at it?
to that many zeros. Do you see that it keeps on going forever and ever and ever? Now, the reason why this one's on the ground is I have more zeros in the numerator than I do in the denominator. So I should, right now, I have it 10 to the 10th for the y-axis, and I have it 10 to the 14th in the x-axis. So if I make this, say, to the 16th, to the 16th, now it'll go, that's 106th. 106th will work too. But to the 16th, then it'll go in the other direction. Oops, I didn't do it right. 10 to the 15th. There, 105th. Let's see if that works. No, I got to go the other way. I got to make this one bigger. Sorry about that. 1004th. Anyway, you get the picture. Okay? Keeps on getting bigger and bigger and bigger in both directions. Next one. Page 166. Let's go through the steps. Step 1. X. Oops, you can't see that. What's the first thing we do?
-5.
-5, and we get x minus 5. Second thing we do. Square root, and we get square root x minus 5. Then what? Add 2. And we get 2 plus square root x minus 5. Next, start with our answer, which let's call f, since that's what they called it. What's the first thing we do?
-2.
And we get f minus 2. Then what do we do?
Square it.
Square it, and we get f minus 2 squared. Is it plus or minus? No. And then the last thing that we do,
Add 5.
add 5. So we have f minus 2 squared plus 5. Recall that the inverse of a quadratic function is a square root function, but only after you make the appropriate domain restriction on the quadratic function. Similarly, the inverse of a square root function is a quadratic function, but you must make an appropriate domain restriction on the quadratic function. So we get back to this step right here. Well, our original function went like this, correct? So whatever our domain was here has to be our range here, and whatever our range was here has to be our domain over here. So if this one in our graph of our function, I got to get back to, I'm going to go a few steps back. Choop, 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 choop. There. Let's go back farther. To 10. Oh, I'm sorry. We're going to keep going back. That'll do it. Okay. Nope. Didn't go back far enough. Anyway, let's set the domain for 0 to... Oops. The domain go from 0 to 100. And the range to go from 0 to 10. Okay, so there's our function right there. The domain here, we want to be the range of the inverse. The range here, notice the range starts at 5. So we will restrict our diagram here to say x is greater than 5. Here's how you do it in Desmos. I wrote my function as x minus 2 squared plus 5. And I should change this to 5 rather than 2. And now when I draw the inverse, there's my inverse up there. And if you notice, it doesn't quite look inversely because I don't have my scale the same in both directions. I should make my scale here be 0 to 100 in both directions. 0 to 100 and 0 to 100. And it'll change the scale of them, but you can see both functions on the same graph. Okay, so restrict the domain. And if you're going to draw both the function and its inverse on the same coordinate axes, make sure your scale is the same for your x's and your y's. We'll start there tomorrow. We didn't quite finish. And I'll go down and clean up a big mess in my office.
Gets better, Kevin.
My day is fine. My stuff's day is not doing real good. My stuff is having a bad day.
No, we got one like September 1st or 2nd.
Yeah?
And they just moved back last Thursday.
Really?
Yeah, so I mean, that long too.
Analytical. Actually, let's just do today.
Morgan, oh my god. No, I want to show you.
I did the revision for
I want to see a video because on Facebook.
Instagram.
Must be a hangout for that.
Well, I'm still trying to find all the information for it. So I don't have anything.
It gets too hot.
And unfortunately,
Huh?
I'm going to ask her in class just to say,
5 p.m. today.
like, half of this doesn't exist. Do I have to just make something up or?
A few points.
Make something up that's believable.